Here's another exponent law. This one is for powers of powers. So, first example, we have an expression, 7 squared, all of that raised to the power of 3. So remember, the 3 is acting on everything in the brackets, the 7 squared. So raising something to the power of 3 just means you take 3 of them and you multiply them together. So at this point, we can use the law we just learned for multiplication. Since the bases are all the same, we can add the exponents. So this becomes 7 to the power of 2 plus 2 plus 2, which is 7 to the power of 6. Or alternatively, you could just expand the 7 to the power of 2, and you have 7 times 7, another 7 times 7, and another 7 times 7. You would have 6 sevens. So how do we get that 6? Well, we're just multiplying the two exponents, all right? And that is the law. So we have b to the power of n times m. And we can use that to do the next two examples. In the next one, notice we have 4 cubed to the power of 2. So all you're doing is focusing on the two exponents, the 3 and the 2. If you wanted, you could go straight to writing this as 4 to the power of 6 using the law, but let's just test it one more time. 4 cubed squared means we take 4 cubed, write it twice, and multiply it. Well, again, if we just follow the law we already know for multiplying, we would just have to add the 3 and the 3. We would get 4 to the power of 6 plus 6, sorry, 3 plus 3, which is 6. And so, again, the exponent there, 6, comes from just multiplying the two exponents. Something like 17 to the power 8 raised to the power of 5th. You'd never ever be required to calculate something like this because it's such an enormous number, or evaluate something like this. But to write it in a simplified exponential form would be quite common. So the two exponents are 8 and 5. Add them together and you get 17 to the power of 13.